Okay, waiting for the stream to go fully online. Waiting until I see the preview in my little window here. So for those of you who have been following along with the study streams, I have made quite a lot of progress in the course off stream. I've had some time in between days, but I didn't have the time or energy to actually do live streaming of it. So I've progressed quite far. But on the other hand, all of the stuff wasn't that interesting to stream, I think. But it was very interesting to learn about everything. And I'm making good progress in the Killercoda, in the killer shell scenarios that I'm following with all of with the course as he recommends. Let's see, what is the status? Yeah, those are checked, that's checked. Looks like I have about half of the Killercoda scenarios done. So I'm now about to do the ones about, let's see, the container footprint here, container footprint user and container hardening. So that's going to be an interesting one. And I also have a container image for an application I've been working on for my home lab that I want to harden a little bit, or at least reduce the footprint. So I'm going to do that. And I want to just repeat a couple of them. One of them being API server misconfigured. That was a really fun one. And actually, I think I'm just going to start with that one. So I've really gotten into the habit of starting, as soon as I get into the scenario like this, I start tmux right away and set -ovi. That just makes everything so much easier. And it has been so annoying to not have set -ovi. So I'm just typing it with every scenario all the time now. Just making my camera a little bit smaller here so that you actually are able to see. All right. All right, let's start this scenario. Make sure to have solved the previous scenario API server crash. The API server is not coming up. The manifest is misconfigured in 3 places. Fix it. Okay, so let's start by seeing if we can see anything about the API server in the CRI CTL, because I cannot do kget pods because the API server is down, obviously. Hopefully you can see the text now. It's big enough for you. So I'm going to start with looking at the CRI CTL, the container runtime interface, PS. And we don't see anything about the API server here. So I'm going to check out the logs. Oh, that's annoying. Why isn't it registering my Control L to clear the screen? Normally it does that. That's annoying. Well, anyway. I'm going to check out the logs for past pods. So if I go to cd var log and then pods and ls here, then here there should be no, there is no API server actually. Okay, so there are no pod logs from any API. So just ls and then grep API. Here we see we get nothing back. So then I'm starting to think that it must be in the syslog. So I'll do journal CTL. Oh, journal CTL. And then I'll go all the way to the bottom. And if I then press, oh, I should turn on my keycaster actually. Let's do not disturb for an hour. And I'll have to turn on keycaster so you can see my key presses. Okay, so now you can see those. And while I'm at it, I'm also just going to start my POMO timer. POMO start. So now I'm starting a 50-minute POMO. I might do 1.5, maybe 2. We'll see how far I go. So I'm in syslog, going all the way down, and I'm pressing question mark to search upwards, and API. Let's see. I'm searching for API, and here I see something about API server. You see that? Namespace kube system kube API server control plane. Connection refused. Let's see if we can get something. Connection refused, yeah. It's obvious that there is connection refused because it's not up here. Here we see something about manifest error. A2C manifest kube API server. Couldn't parse as pod YAML. Line 4 could not find expected colon. So here we have a hint here. So I'm going to open my pane, a new pane. I'm going to go to etc kubernetes manifests. And then I have the kube API server.yaml. And I'm going to open that one in Vim. And here we go. There's metadata. There is a, what's that? It's not a colon, right? Or is that a colon? Well, anyway, I have to turn it into this one. And now we actually have a valid pod manifest. So now we should at least see a pod coming up in CRI CTL. Actually, in this window, I'm going to just do watch N1 CRI CTL PS. So now I can just see exactly what's going on, and I should see the API server come up soon. Maybe there is something more in the syslog that I need to check. So journal CTL again, go all the way down. Let's see, fail to control. We see some errors here, but maybe it has run. Maybe I should just check out cdvar log pods now. Now we see something about the API server. So I'll do, just to make sure, ls grep API. And now we see that we have a directory here called kube API server. So now there are actually logs of the API server stored in my system. So I'm going to go into kube system, kube API server. And let's cat that log and see. Okay, unknown flag authorization modus. So they have set us up with some unknown flag. So I'm going to create a new window again. I'm just going to go to cd etc manifests, kubernetes manifests, and then vim kube API server. And authorization modus. Let's check out the docs, what that should be. API server pod spec. And search for auth. Is there a flag? Audit. Here, authorization mode, not modus. Here is the right flag. So we're going to get back and change this to mode. Quit that, and then let's see if the API server restarts now. It's running for a few seconds. The container is running now. So let's see. Okay, the connection is still, it is still crashing, but we're getting somewhere. So let's go into kube system, kube API server control plane, kube API server, cat the last log. Here we see, okay, error while dialing 2300, connection refused. Let's check out what it's trying to reach then. 2300 etcd servers. So it's trying to reach etcd at 2300. So let's see what the etcd port is by checking out etcd.yaml. And here we see advertise client URL at 2379. 2379. 2379. So etcd servers at 2379. Save that. And the kube API server has restarted. I can get resources in the default namespace, so the API server is up and running. So now, if I check it, it should finish the scenario. Yay, validation successful. So I successfully fixed a misconfigured API server. That was fun. That was fun. Okay, now the next scenario that I wanted to do, I have this note in my Zettelkasten about Killercoda, no, CKS, and then CKS scenarios to repeat. etcd encryption, that's also I'm gonna repeat that one too, just to get everything in the fingers, as we say in Dutch. Back to the scenarios, and let's do the etcd encryption. All right, create an encryption configuration file at etc kubernetes ec.yaml and make etcd use it. So in the docs, I'm going to search for encryption configuration. And here we are at encrypting confidential data at rest. All right. So here's an encryption configuration file, an example of it. So I believe there is a smaller one. Yeah, here. This is a nice small one. So I'm going to take this one. Copy. One provider should be of type ASCGCM, and with the password this is very sec. So let's go and let's see, Kubernetes etcd. I have to make the directory, so let's just cd into there. Cd etc Kubernetes. There's no etcd directory, so make dir etcd. And then vim ec.yaml. So here we have an encryption configuration, and all new secrets should be encrypted using this one. So it's just going to be secrets. ASCGCM AES GCM. We're going to have key 1 and then a secret here. And it's a base 64 encoded secret. And this is the fallback one. And I forgot to do tmux and then set -ovi. So I'm going to do that now. Again, going to go into my etcd directory here. Oh, cd etcd. Here is my encryption configuration, and I need to create a key. So one provider should be of type with password. This is very sec. So what we do, and I remember this, you have to echo with the flag n to remove the new line character. So it's echo n, and then this is very sec. Pipe that to base 64. Here is our secret string. And paste that in. Here we go. This should be our encryption configuration. And create an encryption configuration file at etcd and make etcd use it. Okay. How was that again? Is that use the new? Oh yeah, you have to add it in the Kube API server. Here we go. So that it's similar to here. Encryption provider config. This is the line that we need to add. Copy. So opening a new window here and cd etc kubernetes manifests. Open the Kube API server. And is there any configuration already? Doesn't seem like it. This is the flag that we're going to add. Encryption provider. Encryption. No, there's only this flag here, so it's okay. And then we're going to do etc kubernetes etcd ec.yaml. All right. And now I might have to restart my API server. Let's see. Oh, it is restarting now. So CRI watch N1 CRI CTLPS. Is the Kube API server? Yeah, it is now. It just disappeared. So it should restart any moment. Looks like we have a problem. cd var log pod Kube system Kube API server. Open etc kubernetes etcd. No such file. My head is covering it, but it's saying no such file or directory. Here. Error opening encryption provider configuration file. in etc kubernetes etcd ec.yaml, no such file or directory. That's interesting because I'm in etcd kubernetes etc kubernetes etcd etc kubernetes etcd, and then I have ec.yaml, no such file or directory. What the heck? That's really weird. Why is it saying... What? Okay, let's check the docs. Encrypt. Generate the key. That's what I've done. Write an encryption configuration file. That I've done. Use the new configuration file. You need to mount the... Oh, of course, you'll need to mount the new encryption config file to the Kube API server static pod. I'm such an idiot. I can't just tell, oh, you have to just look at the control plane, Mr. Pod. You just have to mount the entire control plane file system. What an idiot I am. Oh well. Luckily I had this direction in the docs. You need to mount the new encryption config file. So what a donkey. So, okay, let's go back. And now I need to, let's see, close this and cd etcd manifest here. Vim kube API server.yaml. All right. So this is the path, and now I need to mount that path, obviously. So here we see all of these volumes. So I'm just going to copy one of the volumes, add it here. This is the path. Etc kubernetes etcd. That's the directory that I'm mounting. And I'm going to name that etcd ec. And then the volume mount is going to be mount path. Just the same, etcd, and then the name is etcd ec. So now it's not just going to restart. I actually have to move the manifest file away for a little bit. So move Kube API server to the directory below this. Okay. Kube API server is still running, even though I've removed the manifests, interestingly. All right, the API server is gone now. And if I now move it back to the manifest directory, now the API server should restart, and I should see it coming back with the encryption configuration. So watch N1 CRI-CTLPS. Kube API server is back up. Okay, get pods. All right, the API server, Cube API server is running. And it has the encryption configuration. So now I should be able to just check the scenario because it should be solved now. Yes, and the validation was successful. Okay, up next, we need to encrypt all secrets. Oh yeah, yeah, that's fun. Let's see. Yeah. Yeah, here, this is the command. There's a one-liner where you can just get all secrets and then replace it. It's just here in the docs, it's super handy. So just gonna steal that and encrypt all existing secrets in namespace 1 using the new secret provider. So this is the command. So k get secrets n1 OJSON and then k replace f dash. Okay, so now those get replaced. And just to show you what's happening, if I k get secret n2 secret 1 o YAML, here we see that it is encrypted. It has a value here, but this is the value of secret 1 now. But if I run this command and encrypt all of the secrets in namespace 2 again and replace them with the new encryption configuration, now they are replaced. And if I now get the secret 1 from namespace 2, it has the same. Oh, yes, it's not encrypting the. It's not actually encrypting the secret in the namespace. It's encrypting it in etcd. That's what it's doing. So by replacing the secret, I'm encrypting it in etcd. So going back, and then I'm gonna do the last one in namespace 3. And they are also replaced. Check it, and it has validated successfully. Awesome. And the next one, so those were ones that I wanted to repeat. Those were good. And every day I have to do something with RBAC or network policies. I haven't done RBAC for a little bit, so I should do an RBAC scenario too. And after that, I want to get to some fun stuff by reducing the footprint of containers. But let's just do one RBAC scenario. Let's see. Have I done all of the RBAC ones for CKS? Yeah, service account, user permissions. I've done these. Maybe there's something in the CKA that I haven't done yet. Wow, 70 scenarios for CKA. There must be some RBAC here. Nothing? What? I thought RBAC used to be part of the CKA. Here. RBAC service account permissions and user permissions. Well, let's do service account permissions. Start. We have existing namespaces NS1 and NS2. Create a service account pipeline in both namespaces. They should be allowed to view almost everything in the whole cluster, and you can use the default cluster role view for this. They should be allowed to create and delete deployments in their namespace. Okay. Okay, let's check it out. In both namespaces. Okay, tmux set-ovi k create sa pipeline ns1 created in the first namespace, and then I'm going to create it in the namespace number 2. These SAs should be allowed to view almost everything in the whole cluster. You can use the default cluster role view for this. So we're going to create a role binding. Okay, create role binding. Output the help and split the screen, because here I see a very nice little example here. So k create role binding, and then it will be ns1. Cluster role is view, and then the service account is ns1 pipeline. That should be it. And we need to create that in the namespace ns1. Yeah. So k get role binding n ns1 OYAML. So in namespace ns1, we have a cluster role view bound to service account pipeline. Okay, so that worked. That must be it. Okay, set-ovi here too. Then I'm going to do the same one for ns2 for the namespace ns2. And if I now get the role binding to 2, we see that 2. So the cluster role is successfully bound to that service account. Next, these SAs should be allowed to create and delete deployments in their namespace. So I'm going to create a custom role for this. And let's see, just checking the screen, the stream screen here for a bit, but we're good. Then I'm going to switch to the window up here, and then it's k create role help. And now I see this command here. Go down. So k create role ns1d. Verb is they should be able to create and delete. Resource equals deployments in their own namespace. So if I k get role ns1d OYAML, then I see API group apps resources deployments and create and delete. So that worked. And then I'm going to create the role for ns2d as well. That's created, and now it's to create a role binding again. So k create role binding h. K create role binding ns1d. Role is ns1d. Service account is ns1 pipeline in namespace 1. And then k get role binding n ns1 ns1d OYAML. Here we see that the role ns1d was bound to the service account pipeline, so that should be it. And then create it for the namespace number 2 as well. Oops. Service account ns2. So k delete role binding. I created in ns1 accidentally. No, wait. K get role binding n ns2. I have to delete that one. So k delete role binding n ns2 ns2d. Okay, here we go again, because I made a mistake. Create role binding ns2d service account ns2 pipeline. Here we go. Now it should be correct. So let's try some verifications here. K8s can I, and then help. K8s can I get pod in the namespace cube system? Yes, they can get pods in the cube system namespace because they have the cluster viewer role. Now, if I now ask, can I delete pods in the cube system namespace? Oh, wait, yeah, I'm saying can I, but of course I need to, like, I'm now saying can I as the user do this, but I have to, of course, specify that I'm the service account. So let's pipe that to less. And how do I, yeah, here we go. As system service account dev foo. So here we go again. Can I delete pod in namespace cube system as system service account cube ns1 pipeline. Here we go. As the system service account from namespace ns1 named pipeline. No, I cannot delete pods in the cube system namespace. But can I get them? No. Can I view them? View is not a known verb. Can I list them? No. Okay, so is that done correctly then? K get role binding n ns1 Oh wait, I need to create a cluster role binding. Of course, they should be allowed to view almost everything in the whole cluster. Yeah. So K create cluster role binding. That's what I need to do. Can I just edit this? K8s role binding. Can I just turn this into cluster role binding? Error. Nope. Can't do that. So I have to K create. Oh, maybe I have the command here. Role binding. Let's see. Role binding. No. K create role. Create role. Here we go. Those were for the deployments. Here. K create cluster role binding. NS2 cluster role view. Yes, okay. And now change this one to 1 and this one to 1. Yeah, this is why I need more practice with this, because I'm stumbling around too much still. I need to do much more practice with this, I realize now. Cluster role binding and NS2. Okay, get cluster role binding and NS2. Okay. Cluster role binding. Okay, create this one, and this one. Okay, now it should be in both. So, going back, can I list pods in the kube system as service account NS1 pipeline? Yes, haha, now it worked. All right, and if I do it as NS2, yes, but can I delete pods in the kube system namespace? No, I cannot. Can I delete deployments in the NS2 name? Yes, I can. Can I do it in the NS1 namespace? No, I cannot. Okay, I think I've solved it now. I think I've solved it. Let's check it. Yes, nice. All right. At least I managed to figure it out, but I'm taking too much time still. I need much more practice for these RBAC scenarios. Much more practice, because this is too much stumbling around. Too much stumbling around. How is the Pomodoro? 10 minutes left. Okay, well, let's do another rollback scenario, and then after the Pomodoro is done, I'm gonna do some container footprint work. So I am going to go back to the scenarios. Check scenarios. And in the CKA, there is another RBAC user permissions. So this one is going to be about users. Let's check this one out. There's an existing namespace applications. A user smoke should be allowed to create and delete pods, blah, blah, blah. Should have view permissions in all namespaces, but not in kube system. And verify everything using kubectl auth can I. Oh wait, I remember this. I've done this scenario before, but this is actually a trick question because you can't negatively assign role assignments. I'm pretty sure about that. So for now, I'm going to ignore this one. Okay. User smoke should be allowed to create and delete pods, deployments, and stateful sets in namespace applications. Open tmux, set-ovi, k create role-h, open a new one, set-ovi, and now we're gonna k create role smoke, and then we are going to do verb equals create delete. Resource is pod deployment and stateful set. And it's going to be in the namespace applications. Okay, get role and applications smoke YAML. Resources pods. Deployment stateful sets, create and delete. So that role seems correct to me. And then we are going to clear this and then okay, create role binding help. Okay, create role binding smoke. Role equals smoke. And then user equals smoke. In the namespace applications. So K8s can I create pod as, well, what was it? K8s can I K8s can I create pod as smoke, just like that. Can I auth create pod as smoke in the namespace cube system? No. In namespace applications? Yes. Okay, so that worked. So I think this is already it, because this is a bit of a trick question, I believe, but so I'm just going to check it. No, the validation failed. Okay. Well, user smoke should have view permissions like the permissions of the default cluster role in all namespaces, but not in kube system. Oh, now I remember. Yeah, you have to actually create it in all namespaces manually, because you can't do like a role with a scope of some namespaces and then exclude some of them. Now I remember, you can't do that. I'll actually have to create a role for every namespace. So k get ns here. the role already exists. It's a cluster role view. So all I need to do is create a role binding for a user smoke in every namespace. So what I'm gonna do is I'm gonna create cluster role binding help. Create cluster role binding smoke. Cluster role equals viewer. No, view. And then the user is smoke. And then the namespace is, let's start with default. Yeah, so get ns. I have to create in default in kube node lease. No, I should not create a cluster role binding. It has to be a role binding in every, yes, oopsie. So delete cluster role binding smoke, because yeah, cluster role bindings are not namespaced. What a donkey. Again, create role binding smoke, cluster role view. Yeah, this should be it. So kube node lease, default. And then we're gonna do it for namespace kube public. Can I do a comma separated list? Local path storage. No, you can't do that. Okay, kube public. And I'm gonna create it for the namespace local path storage. Okay, so now I've created a role binding to the cluster role view in every namespace, and now I should check, and the validation failed. Okay. Get role binding smoke. And local path storage. Oh, YAML, what does it say? That's weird. He has the cluster role view. Has to be cluster role view and then the user smoke. And that is in all namespaces now. Oh wait, I didn't create it in applications. Maybe that's it. And applications. That name already exists because I used that for the other role binding. Okay, so now we should do it. Yes, yay, validation successful. So I had forgotten to do it in the applications namespace. That was the problem here. But what the doubt that I had is this. Let's check the hints here. You have RBAC info and yeah, here it says, as of now, it's not possible to create deny RBAC in Kubernetes. So we allow for all other namespaces. So you actually have to do it for every namespace. You have to create it because he should not have the cluster role in the kube system namespace. So you have to go and use it for every namespace. Hi from Copenhagen. Ah, hello. I work for a Danish-based company currently. I speak Norwegian, but no Danish. but it's I work for a company that started an office in the Netherlands, so that's cool to have someone from Copenhagen here. Can it be K8s role binding and all? No, because it doesn't have to be in all name. It shouldn't be in all namespaces. It has to be all namespaces except kube system. So that was the problem, but now it worked. So we are golden. All right. My Pomodoro timer has ended, so I'm just going to take a quick break, maybe 5-10 minutes or so, and then I'm going to work on some Docker files. So let's see, Pomo start, and then start break. On a break, yeah, I probably won't take the full 10 minutes, maybe 5-8 minutes or so, but I'm just going to stretch my legs and I'll be right back. Okay. Getting everything back in order here and just fixing up my setup a little bit. Here we go. Off to the next round. Let's see. Okay. Where can I get that Pomodoro timer? The Pomodoro timer, the configuration for it is in the .files repo, but the Pomo itself, that is created by the one and only RWX Rob. So it is a Go binary, and you can get it for yourself. It's in RWX Rob Pomo. Here, it's a Go binary that you can install, and then if you look in my .files repo, you can see the tmux configuration for it, how I've set it up. So now I've done my daily practice with RBAC, and now it's time for some container image footprint. I just finished that bit of the course, and yeah, here image footprint, and now he was instructing me to go to the scenarios. So we're gonna try those, and I have an image of myself that I want to tune a bit. So let's check it out. Container image footprint user, and we have a queue. Oh, that's because I have this one still open. So delete that one. Here we go. Let's see. There's a given Docker file under opt KS Docker file. Build an image named base image from the Docker file and run a container named C1 from that image. Check under which user the sleep process is running inside the container. Sure, so tmux set-ovi. And we go to opt KS. Check out the Docker file. All right. So we see that it does a run add user. So it's adding a user, but it's not actually running as it yet. But we can do docker build t base image. Dot. So now it's building. Then docker run C1. It needs to be named C1 from that image. And then base image. This should be... Oh, no. Docker run base image and then name C1. That's probably it. Docker run. What is it? Isn't it name? Grab name. Yeah, assign a name to the container. What the hell? Docker run name C1 base image. That's taking a long time. Oh, of course, because it is a sleep command. So now it's actually running. So I'm opening a new window. And if I do docker ps, now I see the image. It's running, and it's having a sleep command. So it's just opening. It has the terminal open. I don't have it running detached mode. So it's just waiting for the sleep command to finish, which will take 1 day. So if I now docker exec it bash or sh, here we go. Then now I'm in the container, and now we have to find out what user the sleep process is running under. So ps-aux grep sleep. We see that the sleep command is running as user root. Check. Successful. All right. Modify the Docker file to run processes as user app user. Update the base image with your change and build a new container C2 from that image. Sure thing. Exit the container. So docker stop. Docker ps. Docker stop this container. So that should free up the other shell again. Yep, it's freed up again. Okay. So we are in apt.ks. We have the Docker file, and then I believe it's as simple as just running user app user like that. I believe it's that. Then we're going to build it again. Okay, so that is built. And then we can do docker run. And then I'm going to do it in detached mode. Docker run d. Docker run name C2 base image in detached mode. Okay, so it's running docker ps. And then docker exec C2 shell. Huh? C2. Oh, exec IT, of course. Exec IT. Here we go. Now we're on the shell. And then ps-aux grep sleep. It's now running as app user. Yeah, here we go. I was confused by 1, but root user ID is 0, of course. So yes, it's running as app user. So it works. So the scenario should be solved. Yeah, and this validation is successful. Hooray. Now the next one is scenarios. Here's scenarios. The next one was container hardening. So let's check out that one. Container hardening. There is a Docker file at root image Docker file. It's a simple container which tries to make a curl to an imaginary API. Use a specific version for the base image. Remove layer caching issues with apt-get. Remove the hard-coded secret value. Pass it as an environment variable and make it impossible to podman exec. Okay. tmux set-ovi cd root image vim docker file. What do we see? From Ubuntu. Okay, we tag it to that version. Remove layer caching issues with apt-get. Then I have to put this on one line, I believe. Apt-get update and apt-get install curl. And URL, that's the URL. Okay, so I have to give it another environment variable, env token. Just give that token, and then this should be token, right? Remove the hardcodes. The secret value should be passed into the container during runtime as an env variable token. Then make it impossible to podman exec, docker exec, or kubectl exec into the container using bash. For that one, I believe it is run rm rf bin bash. I think that's it. Let's just try it. Podman build dot. Env must have 2 arguments. Okay, so what is that, the default value? Okay. Okay, so it's building, it's updating. Okay. Do we have to run it or, well, podman image ls. I have to try it, right? Let's tag it with Misha. Podman run. Okay, so that works. Podman run detached Misha. Podman exec it Misha bash. Podman ps. Oh, it's not running. Oh yeah, because it just runs and then it closes. Well, let's check it out if it works. Okay, you solved the challenge. It already works. All right. Well, that was easy. Great. Well, what I next want to do is, the other day I was doing this fun project in my GitHub. So github.com/Misha Vandenberg. Check out my repositories, and I have this Zettelkasten tracker. This is a fun little project that I started last week. This is a binary that checks out that looks at the number of nodes in my Zettelkasten and then pushes it to Prometheus. So now in my Grafana, in my home lab, I have this graph where it actually shows the amount of nodes in my Zettelkasten and as it's growing. So over the last 7 days, I see that my Zettelkasten nodes have grown from 2,556 to 2,310. So that's quite a significant increase of nodes in my Zettelkasten. And this information is very important to me. So I'll show you the Postgres cluster that's running this. This is all running on my Kubernetes home lab. And my Zettelkasten tracker database had a base backup to Azure, so everything is backed up to Azure Blob Storage and has been backed up 14 hours ago. It's running with 3 replicas, and interestingly, it's utilizing its memory quite more than I expected. So that's cool. I might have to increase the memory a little bit. But the Postgres cluster is looking very nice, even for such a silly application. And I wrote it in Go. So this is the Go code. It's just very simple. It has an init, and it constructs a database connection string. And then it counts, it serves an API that listens on /count. And what I then do is I have a cron tab. I have a cron job that kicks off the zk count script that I have. And then if I go to my scripts directory in my .files repo, zk count, here is the script. It does a find command in my Zettelkasten and then counts the lines, and then it pushes that to the API that's served by this Go binary that I created. And all of that is running in my Kubernetes cluster, in my home lab cluster. If I just switch to the Zettelkasten tracker repository, here you see that I have it running in a pod and with 3 replicas of the database, no less. This is very important information to me. And here's the running application. Now the thing is, I created this thing with a Docker file. Just go into my repo here, and then Zettelkasten tracker. I created this Docker file, but today I learned that I can... oh, okay, I'm already doing it. Oh, I forgot about that. Oops. Well, what I was thinking was I learned about multi-stage builds, but I forgot that I'm actually already doing that. So I'm running this stage as the builder, and then it compiles the Go binary, and then it copies that into the next stage. Yeah, so the image is actually very lean already. So if I do docker image ls grep z. Oh yeah, all right, it's already 22 megabytes. I thought it was much larger. But it must be an older project that I did. I was confused about. All right, turns out my Docker file is already following best practices. And in many ways. It is, I just set this up really quick. I haven't put much thought into it. But now that I look at it, it does use multi-stage builds to save some time, but it's not running as a user though. It is still running as root currently. Check out the home lab code. Yeah. Yeah. Good point, Edward. I was just getting into that. I'm running it as root, so that's an upgrade we can do, or an improvement we can do here. So just I just wanted to show you the GitOps code for this application that I have. Here's the Zettelkasten tracker, and the customization file just reads in the base, which reads in the deployment here. So I haven't optimized the security for this yet, so I can actually do that right now. So I was running it as the root user here in the container. So we can do run, and then where was it? The Docker best practices. I learned about that today. Let's put that on dark mode. Here we go. App user. Wait, is that not here? Or Docker file best practices. User. No way, that must. Here, app user. Really? It's not listed as app user. Okay, that's interesting. User. The course was talking about the Docker best practices, so I'm interested in how they tell you to do it. Here, run group at Postgres. All right, if a service can run without privileges, use user to change to a non-root user. Yeah. Start by creating the user. Okay, so they do explain it. That's good. I wouldn't have expected otherwise. I was a little bit shocked, but run group add or Postgres and user add. Oh, that's a nice command. Well, let's try with this command. So group add or Postgres. Let's call it app user. So app user, and then user, app user. Okay. And then the workday root. Do we want that? Well, let's see if this will work. Okay, so Docker build. Up version here. Oh yeah, in Alpine it doesn't have the group add, right? It has a different add user Alpine. Here, add group, add user. Here, this is it. Of course. Now it should work. Docker build. Like this is fun. I'm usually I work always with setting up the clusters and deploying the infrastructure and Terraform, but I actually don't do much with Docker files and building applications on the daily. So it's going to be it's much more fun to see the other side of it a little bit, and so it's nice to understand more of what I'm actually deploying on these clusters. And that's why this little project is so nice, because it's a silly little thing to see your Zettelcast and stuff. But yeah, to optimize everything for security, like now I'm making a small little step by running it as a non-root user, but I'm going to optimize the hell out of this. I want to get into all of the Go code, and I want to make this as secure as I can, and I will learn a lot in the process. But I have to, like now I have the goal of the CKS exam, and I have to focus on that. But this actually is related to the CKS exam with the user and such. But I have to resist the urge to get too deep into the Go code, because that's what I really want to learn. And I also really want to learn the CKS. I'm having a ton of fun studying for that. I just have to make sure that I don't get distracted. So it takes a while to build this, actually. So I definitely have some improvements to make in the security context as well. I wonder, I'm running it as user add user. I have to give a number here, right? In the security context. Let's see. Security context. It always has to be on a user ID. So I have to give it a user ID as well when building the Docker file. Okay, the building is done. So Docker run let's try to just run it on the Rancher. Do I have Rancher desktop running? Yes, I have. Docker run. This one. The platform does not match. So that's because I'm running a Kubernetes cluster on the. I'm now on my N1 Mac. So this is going to be interesting if it can actually run a AMD 64 on an ARM chip. I don't even know if this is going to work. Docker PS. Grep Z. Looks like it's working. Docker exec IT bash. All right, here we are. Yeah, we're running as app user now. That's good. So it's working. And interestingly, I get permission denied. So ls, I can root the. That's interesting. I can list the root file system, but I can't ls the current working directory. Okay. Okay. Well, is the thing actually serving now? And this is going to be tricky because I have it already set up on my Kubernetes cluster. Well, anyway, I made an improvement here on my Docker file, and that's as far as I wanted to go today. The POMO timer has reached 10 as well, so I'm wrapping up the studies for today. I'm very happy with the progress I've made, and I've done some good practice with the RBAC. So thank you so much for tuning in, guys. That was nice to get some input there. And I'm going to be continuing the CKS studies. I've now finished the image footprint section. And
processes.
When that's done, I have about 4 hours left. And then I can really start preparing for the killer shell. So I actually think maybe a week, maybe in 2 weeks, I'm going to go for the CKS exam. So I plan to do more CKS streams in the meantime. So thank you so much for tuning in, and hope to see you in the next one. Have a good day, everybody.